Hey everybody! Welcome back to A to B. This will be the final episode because, well, we've reached the end of the game. So let's begin. Aftermath. I forgot to press record again. I'm now recording. Maybe I should just record from the start of the stream. That's probably the best option. From a previous student to professor. Hello, professor. Do you still remember me? I took your compiling principles course 5 years ago. As a class project, I designed an original programming language, A to B, and its compiler. I got a lot of guidance from you in that period. I am writing this email to share my recent activities. First, after the semester, I decided to become a game developer. My first work was named as Yap, yet another puzzle platformer, in memorial for Yak, yet another compiler. Second, I had a nightmare about exam week a few days ago. When I woke up from the dream, I suddenly realized that every keyword in A to B is actually not necessary. I should have passed with my first submission. Course report. Alright, the bug is crawling up my leg. I'm sure that's not a problem. Okay. A to B is a minimal programming language designed for compiler principles course project. It has the advantage of simple syntax, easy to learn, convenient to code, and convenient to code its compiler. Yep. Yes, believe your eyes. All keywords are not available in the chapter. Will prove keywords are unnecessary. They are necessary, but not for every program. Following characters are reserved equals and hash. Then this we know how this game works. Proof of turn could need us. We don't have this keyword anymore, buddy. Your proof doesn't work. Doesn't work, buddy. Okay. Like every time this has messed up my entire screen. Let me give me a 5 seconds. 4, 3, 2, 1, go. Hello again. Input, a string of A, B's, and C's. Output, hello world. You may not use keywords in this level. So this is quite easy. A equals A, B equals A, C equals A. Oh wait, hang on. We do it the other way around. B equals A, C equals A equals A equals hello world. There we go. Easy peasy. Read from your previous student, from professor. Hello! Of course! I remember you for your unprecedented solution. In the next semester, we modified the requirements for course projects to prevent more submission like yours. By the way, you should have noticed keyword is not necessary 5 years ago. If you did so, and prove its completeness in the beginning, I might be angry, but I would have let you pass anyways. Input, a string of A, B's, and C's. Output, return true if input string is a palindrome. Otherwise, return false. You may not use keywords in this episode. Okay, this one's slightly harder because we're not allowed to use messages of this form. That will trigger the false flag. Still probably doable. It's gonna be a bit harder though. Yeah, this is not an easy one. So I suppose we would have to somehow start deleting characters, but in a way that doesn't delete them. And once again, we can't use something like A equals. That's the annoying part. We can't do that. And the issue is CAC could actually accidentally destroy too much data. Is the other issue. Yeah. Somehow it would have to be a process that we can... Basically kind of like a reduction. If we can somehow reduce the problem step by step, so that at each step the problem does not change. So we're still trying to find a palindrome. That would be the ideal scenario. So like, we don't want to delete a BB, but maybe we want to transform the BB in a way because the other issue is if we start deleting too early, then we run into issues. Yeah, I would love to do A equals. That's gonna go badly very quickly. But that one constraint, it actually is impeding a little bit. Because what if it's just a letter A? How do we deal with this? It has to be at least 2 letters. That's probably the reason why it can't just be the letter A. So we have to reduce it to 2 characters. Maybe like AA? Can we somehow reduce this to AA? Yeah, like AA equals A. Well, that doesn't work. That won't work. Capital A? Maybe? To indicate that we have created a reduction. Like, the cheeky way we can do this, because there is a maximum input length. I feel like we could brute force this. I don't know if we want to brute force it though. Let's try this. BB equals B, CC equals C. Okay. I don't know if this will do anything. Except now we have some A, B's, and C's. I also feel like there's wind underneath my feet. That was so weird. Yeah, I think there is a method of brute forcing it. Okay, so we need to see the worry I have is right now. Let's take this one. If we reduce it by deleting these B's, now it's going to be correct, but previously it was incorrect. So somehow we have to delete this. Yeah, I think the bug is flying around on my lap now. But we have to be able to make a selection of a center that, if this is correct, then if this solution is correct, then we can select the center. And I'm also, yeah, this is the issue. A, B, A, A. If we accidentally select, or if it's like this is correct, but if it selects B as the center, in this case it's not going to work. So these are things I have to worry about. And I can't use A equals. That's the other issue. If I could, I think it would be a lot easier. Is there a way of detecting only A's, maybe? Um. So maybe the answer to our woes is to somehow reduce a problem to just A's. Maybe. And some capital letters that we can move around. Is there a way of detecting? Because if we could transform this into a problem that only has A's, that would be wonderful. The issue is, of course, then if we have, say, BBAA, if we transform the two B's into A's, then now it's going to be correct, but previously it was incorrect. So, once again, it's just going to reduce down to the problem of the center. BB... So if it becomes AAB? BA, maybe? The point is I want the A's to slowly cancel. To just remove the A's gradually. Or we remove the B's gradually. Is there a process that... No. AB... I mean, we can make dividers. We can do like AB becomes ADB, BA becomes BDA, AC becomes ADC, CA becomes CDA, BC becomes BDC, CB becomes CDB. And then maybe somehow? And now we... Then maybe D... No, we can't. We have to do it at the end. So D becomes... DE? Okay. Hang on, no, we have to do this at the very end. I think there's something underneath my X key, so that's preventing the key from being pressed properly. So now we've divided all the ABs. There's a D. The first D will spawn an E. Or maybe we do EV. Or FE? And then the E's will do something? I don't know. Actually, this kind of builds a Turing machine, now that I think about it. Because now we have a cursor. Except we can't detect when it's ending. When it's over. That's the one thing. I guess maybe we can. No, we can actually. Never mind. Okay, let's do ED. And then we go AED becomes A, maybe? Maybe we can do this here in one go. Bug, can you leave my keyboard, please? C. And what that does is, well, AD we can do this. AA becomes AA. C becomes CA. AD becomes DA. And then we repeat this for all the other ones. Becomes AC, CB becomes BC, C becomes CC, and CD becomes DC. Okay, so now these letters will traverse all the way to the end. And the idea is that they will have to cancel out. Why is there... The bug is bugging me. So be it. DA A becomes nothing. DB becomes nothing. There is one case I need to figure out. Okay. And then anything else? C becomes F. And F is... We'll deal with F. Actually, we'll deal with F now. There. So we've successfully done it in the case of false. If it successfully deletes, then it will delete properly, otherwise there will be an F. Now the only issue is true. So the issue is with this program is eventually we'll get... So let's say it was BAB. It'll become BD, ADB, and then the way the program works is it will delete these two. So it'll become A. Now we've run into an issue because we can't write A equals. So we need to do... We can do something... Okay, we can... There's an easy solution. True, false does not use the letter G. We will substitute A with G. Since we're doing this anyways. Actually, hang on. Now we can just do whatever we want with A, B, and G. Or B, C, and G. So we can do B equals B, C equals C, G equals G. And then we do the same thing. So we do this first. Because we have a constraint of 2, so we can do this. So BB equals BB, BC equals CB, BG. I have to get used to using G, GB. We do the same thing. Let's see, CB equals BC, C equals CC, CG equals GC, GB equals BG, GC equals CG, GG equals GG. Okay, and now if we end up at the end, so BB becomes delete, CC equals delete, GG equals delete. And now I think we have an easy way out. So if we can do CB equals F, GB equals F. What's the other ones? We need BC equals F, GC equals F, BG equals F, and CG equals F. And the reason we do that is at the very end, B equals T. Oh, we can just directly write that true. C equals true. G equals true. Oh, we also have the case when there's nothing. We need to deal with that anyways. Okay. In which case, we're going to do that. I guess we could do it a slightly different way. So what I think we'll do is we'll do E for end. So that'll be end. EE becomes E. So it'll go all the way to the end, and then it will remove. Okay, so there will always. So the first time we do this, there's nothing. Then every other time there's going to be a character at the very end. So that's how we're going to detect everything is going great. B equals. Oh, I guess we could have done. Hang on, go back. Okay. So what we can do, E, 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 EE becomes E, and what we'll do here is we'll just do this. Okay, BF equals F, CF equals F, GF equals F, and then F equals false. Okay, so that's that. Now, if it's true, we will either have B, E at the very end, true, CE equals true, GE equals true, or just the letter E. Okay. I think this will work. Give me a moment, I need a bathroom break. But okay. Why did it not work? GG. Okay. I see. We have to actually use divisors. That's very sad. All right, let's erect them. So this almost works. There is one issue. Yeah, so we have to do the divider method. This will work, but we need the divider method because these need to go in order. So Okay, actually, so we don't need the second letter then. Because we need to do this. Oh god, this is... I hope that there isn't like a... I'll be gutted if there is a very efficient optimal solution. Yeah, this one stream will last 3 hours on its own. Okay. So what will happen is D will become ED. And then there we go. That's how we do it. And now we just have to make sure everything has a divider. So BB... I guess we could do BBD becomes B. At that. And so... here we will... yeah, okay, we do the same thing. AAD becomes ADA. Okay. Oh wait. Maybe we'll use different letter. G. That's an homage. That's my previous idea. Okay. And this time I'll comment it when I finish the solution. But I need to finish cooking first. Yeah. BB becomes E. So wait. That's not quite what we want. I think what we want is D. Yeah, we want to change this. So we want DBB becomes E. DCCC becomes E. DAA becomes E. EE becomes E, that's correct. Everything else... something BC... BD... BA... CB... CA... AB... AC. And this will delete everything. EF equals F. F equals false. That's done. D becomes GD. Okay, yes. So if we encounter an error with the parsing, then we get false. If not, we either reduce down to the case when we have BE. Oh no, it'll be lowercase actually. There won't be any D's left. So AE. True equals true. Okay, wait. Oh, there's still a G somewhere in here. Where does the G come in? Here for some reason. Oh, this has to come here. There we go. Oops, wrong button. I forgot to do... I forgot the case AA equals A. Hang on, let me put it at the bottom. A becomes ADA. BD becomes BDB. CC becomes CDC. Okay. So we should be able to put all the devices in. Okay. Now this should run all the way down to the... Oh, maybe... Okay. AD. Oh. Did I forget to put... Ah, fair enough, fair enough, fair enough, fair enough. I could actually just do it directly. No, we can't. We need to do this first. Be true. I guess... Okay, I guess we should probably reformulate this slightly. And we would need to... I guess we would need to move to D first. Becomes... Okay. Yeah, just move to D's in front. Then should be fine. D. 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 Now we need to do... D. 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 Okay, and once we're done, it will in fact be the other way around. And we're back to that because probably reasons. ADB. Yeah. Perfect. Oh, the first D is not gone. Yeah, why did I overcomplicate it? I could have simplified it so much nicer, considering the fact that we only run into... This part only runs into issues if we... Okay. Can I change it back? Okay, I can do this. Okay. This is fine. We just need to do... Never mind. We need to do something else as well. Was this the... Was this the fixed one? It's not the fixed one. Ah, I see. There we go. Okay, that got stuck for some reason. Okay, I think one of my commands could be wrong. So did the dividers get put in properly? Yeah. Then we have B becomes capital. Goes all the way. Bubbles, bubbles. Bubbles? So DBA. Oh. There we go. Please. Don't force me to optimize this code. Okay. We're doing the hacky solution. Come on. $20. Okay. 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 We'll try. I think I have an idea. It's a very similar one. Oh, fuck this bug. GBBA equals GBA. AC equals G. AC. CA equals GCA. I think we have to do all the cases, including AA. I suppose we could do that instead. Because if there's just a single A, then we're done anyways. Then what we do is we do BG equals GB, CG equals GC, GA becomes capital A. C. We use that line up the lines already. BC equals CB, CA equals AC, BC, CC equals CC, AA is nothing, oh no, sorry, AA is nothing, BB is nothing, CC is nothing, and we're almost done. We've almost hit the limit. So what is this gonna do? Maybe we can do this. C equals A, B equals A. So yeah, this will delete everything. Maybe instead it become D. 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 Um, I wonder if this approach just can work. Okay, let's try this approach anyways. Just get it to work, and then we can see if we can optimize this approach, because I think we can get it almost there. AA equals D, B equals D, CC equals D. Okay, if we've reached that part of the program, this part of the program, then we just write B equals, or we can just do B equals A, C equals A, AD. Ah, okay. Okay, we can do this. Then we can do AA equals AA. AA equals false. A equals true. DD becomes D. D equals true. Okay, there we go. We got this probably in. Whoops. Okay, so this will be almost correct. I'm sure I'm gonna hit one of the edge cases that I haven't thought of. Biscuit. I shouldn't be eating on stream, but biscuit. Biscuit. Trying to make the sound of the munching not be heard. Maybe I should just mute my microphone while I munch. But that'd be a hassle. I'll just sit really far away when I munch. Okay. So now we have to optimize this code. We have to remove 9 lines. I might have a little bit of a dumb idea. But I think my dumb idea does work. Okay. We're gonna use the constraint. Because what we're gonna do is that C equal 1, 2, 3, 4, 5, 6, 7 B's in a row. Because, well, maybe 10 B's in a row. Because if there's 10 B's in a row, it has to be a C. Ah, Scratch that, this will not work because it can't detect the difference between BC and CB. If there was a way of doing that, maybe. But it would also have to be a palindrome. One, two, three, 4, 5, 6, 7, 8. I think this works actually. And this will allow us to remove the C case. Maybe we can even change it so that if it's just a bunch of A's. Hang on, we'll keep it for now. This is so dumb. It's also running so slow now. Perfect time to have another biscuit. Okay, I think I proved it works. So we'll only do it on the final result. One more biscuit for the road. Biscuit. Oh wait. Okay, let's run this program. I'm just gonna sit back now. Oh crap. I can be... No microphone. Don't pick up my crunchy noises. Ah, that was a very good cookie. Yeah, this code is... I made this code 10 times more inefficient, but I cut down like a third of the number of lines necessary. Now, it's entirely possible that I'll hit the string limit if it's 7 C's in a row. No, it won't. The string limit is 255, I think. 7 C's in a row will generate a string of length 49. Well below the limit. We're not even a third of the through. Because it's checking every single one. Technically, given the constraints, we could just list out every possible answer. It'll be a program that will have like 3,000 lines, but it is a valid program. I think running this program on its own is actually gonna take like 3 minutes of the stream. Ooh, the nib of a pen I found on the floor. Picked it up with my toes. What else can I do while I wait? So yeah. This is a very interesting game. I mean, I spent an hour on the second problem. So hopefully the third problem doesn't require me to take another hour. I assume if I have to, we still haven't run into a bug, which is great. Considering the fact that we're reducing the C to a problem with just A and B, we shouldn't run into a bug because the program works. But I think we can make it more efficient, because if it's just a string of A's, then the problem is solved. So we probably don't have to do this, but doing it anyways. This way works anyways. Yeah. How many batteries can I balance on my hand? I've got all of these AAA batteries. Look, I bought a whole pack of them. I have a whole pack of AAA batteries. And I bought them for this mouse. The issue is, wow, this mouse works. The issue is the scroll bar doesn't. Wait, what? Wait, hang on a minute. What the heck is happening? Okay, this is so weird. So, we finally reached 6,000. I have two mouse. Now, at some point, this mouse was no longer working. By which I mean, the scroll wheel wasn't working. So I disassembled it and I determined that something in it snapped apart, which caused the wheel to disconnect from the thing that detects the wheel. So I thought, okay, it's broken. The scroll wheel doesn't work anymore. So I bought a new one. And now this one works. Hooray. We did it. So now I just have 2 mice. Cool, I guess. I mean, they're both nice mice, but I like this one more. I'm gonna use this one for now, though. I'll have to check, because it was definitely disconnected. Like, you could take the mouse, you could take the wheel apart, and then there was a bit that was sticking out. Maybe there was a tiny bit of glue that hardened enough to actually make the scroll wheel work. I'll have to check. Or maybe it was always designed that way and I just messed it up somehow, but just to reiterate what's happening. Basically, the way this one works is that as long as there is either 2 A's or 1 B, that means that we still have to process the palindrome a little bit. What we'll do is we create a G. We bring the G all the way to the front of the string. Actually, we can even remove this line, so we can make it shorter if we want to. Oh well. Yeah, we could have made it 1 line shorter if we wanted to, by removing this line, because this line will never happen. So be it. So what we do is as long as there is some characters left, we will spawn a G. The G will travel to the front of the word. Then it will transform GA into a capital A, GB into a capital B. These A's and the B's will travel all the way to the end of the string, and then it will delete itself. If it can. So that's the D for delete. Otherwise, it would just stay at the end, and at the very end here, we check to see if there are some A's and B's left over, which didn't properly cancel out. If there is some left over, then we output false. Simple enough. Now this code works for A and B. Since we have A, B, and C, what we do is we transform C into A, followed by 7 B's, followed by A, which, because of the constraint, can never happen properly. So we can save, we can reduce the A, B, and C case just to A, B, and B. And because of the constraint, this string will create, this will be, the input will be a palindrome precisely when, if we replace the C with this string, it's a palindrome. Very fancy. Okay. Okay, thank you for sharing. I just came up with a weird idea. Design a programming game based on this experience and use our email correspondence as its flavor text. I'll modify content of some emails that involve private information and add a "this is a work of fiction" note. Hope to get your permission. 6.3. To be or not to be 2. Input, a string of A, B's, and C's. Output, if at least 1 B occurs, replace each A with a B. Otherwise, replace each A with a C. So we only need to do this program if there is an A. So probably we'll do GA. Okay. Then we just need to do for B and C, right? BG equals GB. CG equals GC. Then what we'll do is G equals H. So we'll bring it all the way to the... Oops. We'll bring it all the way to the prompt. And now what we'll do... Maybe HA becomes AH, HB becomes FBF. HC becomes CH. And what we'll do is we'll do AF becomes FB, BF becomes FB, CF becomes FC, FA becomes BF, FB becomes BF, FC becomes CF. I don't know if this is the best way of doing it, but we'll do it anyways. F equals nothing. Otherwise, H is equal to I. AI becomes IC. CI becomes IC. And we're done. Oh, we need to remove the I. There. Fair enough. Yeah, we need to bring it all the way to the end. Maybe BE. Oh, no. We can do EF, like that. And then this, we do this, and then this, we pass with E. There. There we go. Now, hang on. So that should become that, yeah. Why did it become an F? Oh, right. I just realized I need to shoehorn the explanations of the code back in. Thirteen lines. Okay. So I think still becomes, yeah. So maybe, okay, A becomes, could we just do that directly? GH, something like that. And then something like BC becomes A, B, C, C. Or E, B, F, C. CB becomes E, F. No, C, E, B, F. H, B. B, G. And all E does, BE becomes EB, CE becomes EC, HE becomes E, GE becomes E. Same thing with F. FB becomes F, FC, oh sorry, BF, CF, FG becomes F, FH becomes F, then we delete E, then we delete F, and the very end, GBH becomes C. Oh, we need to do... Right, this doesn't quite work. It almost works, but not quite. And anyway, we're over the line count anyways, so delete. Okay. A equals B. And and it only works in the case when there is at least one B. Problem solved. I mean, literally. No, it doesn't work. um... Somehow the other way around might be easier? I don't know. A becomes... That might not be the worst idea. Maybe? I don't know. Because somehow we'll have to detect when a bee is outside. Maybe... Might this be the solution? And... No, that is harder, because then if there's no bees, we have to then turn this into C. I think that's harder. I'm just trying to find a clever way. I think this has to be it. Oops. BG becomes maybe BE? Probes. How do we probe? Yeah, so think there is... I do think we have to build upon this idea. I don't see any other way of doing it. Is that line missing? Oh, there it is, yeah. 6 lines we have to remove. I think there is a way of doing this. Maybe here we replace it with B. B? I don't think this helps. Ah. I don't know. Okay, let's play with this concept a little longer. So at the end we want G, B, H. If there is a B that does not lie in this, we want to replace it with C. And then it's just in the middle. How do we do this? Maybe CG equals GCG? Nope, because they'll create an infinite loop, right? Yeah, they'll create an infinite loop. So we can't do that. So maybe lowercase gcg. And then bg. That's when you want to explode. I guess same thing with HCH. And then HB becomes EBF. And that one is, we'll do that first, I suppose. CE becomes EC. BE becomes EB. HE becomes EH. Oh no, just E. G becomes E. HE becomes E. G. GE. That doesn't quite work, does it? Maybe that concept is too complicated. So maybe we could use numbers. That might help me with figuring which stage we're in. And C1 equals 1C. So 2. One becomes 3. Maybe we change this to 3. To a to B becomes 3B. 3B4. B4. Two. I'm basically just rewriting the same program at the start. This variant. And then here, but then we still did 3 before. Yeah, okay, this doesn't work. That's just the same program we had in program 1. So it works, but it's taking too long. 13 lines. Is that something? I don't know. Like an echo. Echo, 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 echo. It's like BA becomes BB, AB becomes BB. Okay. So now we do echo, I guess. So like CA becomes CA, CC becomes CC. How do we do this? Okay. So now we've converted. So now we'll have B's separated. So either we have A's separated by C separated by A separated by C's, or we have B separated by C separated by A separated by C, A, and so forth. Okay, so what would do? I guess CA becomes CA, CC becomes CC, AC becomes ACD, DC becomes CD, DA becomes A, A becomes A, AC becomes A, E, EC becomes but this again, this is too complicated. too complicated. I'm sure there's a clever trick. A fly. A fly. Hello, my little fly. Is there merit to doing this? B, A, C. Huh. BAC. B becomes BD. D. C. CD. B. A becomes B. Right. CE. Oh wait, we can't have it be EC. A. But then I would have to do... I think this doesn't work, right? See. Yeah. We need another one. Okay, we got it down to 15 lines, which is a big improvement. Very big improvement. Now, how do we get rid of everything else? That's the question. BC, so... I think we still need to do it this way, but... because we have to make sure we don't loop forever. CA equals AC, CB equals EB, and EB. How do we remove 2 lines? That's the question. We have to remove E. Oh, do we have to remove E? Probably. Okay. Guess one more try. AB becomes... Maybe I shouldn't delete this, because this is the closest we've gotten to an acceptable solution. I thought this would be done and dusted, I'm gonna be honest, so considering the fact that we're taking too long, we're taking this long. No, this doesn't work either. How can we improve this? How? We've reached the 2-hour mark. I had a dumb idea, but it's a bit too dumb to work. Wait, maybe this works. Hang on. Okay. A becomes 1A. So 1A Okay, yeah. C1 becomes 1C. B1 becomes 1B. Maybe we do 1, 2. Oh, sorry, no. We don't want B. We want B3. 3C becomes C3. And then 3A2 becomes B4. If one reaches the front, we don't care. And the idea is 2A becomes okay. B4. So we delete 1 if it reaches the front. And the idea of 2A we'll transform all of the as we travel along. Yeah, so I think maybe we can even not have a 4. We just have a B. Like that. So it'll do the thing first, then it'll become a B. And if we reach this stage, then we can just keep going. Repeat as... Then we can repeat the loop. It's if we have a 2. What we'll do is we'll transform B and 2C equals C2, and if we reach the end, that's when we'll engage 5. A5 becomes 5. Oh no, B5. 5's B. Sorry, 5C. C5 becomes 5C, 5 delete. I think we have to do B. B here. There we go. So basically what this does, this code. So we have a 1, so for each A, we'll have a 1 and a 2. A 1 and a 2. The 1 will go back to check if there's any B's. If it runs into a B, it comes back and removes the 1 and 2. So we've transformed one of the A's into a B, we're happy, we can restart the loop. If it travels all the way to the end, the 1 will delete itself, and now we're just left with the 2. And what the 2 is going to do, it is going to transform all of the A's it encounters into a B until it hits a B. Which means that all of the B's have transformed correctly, and we're done. If it reaches all the way to the end, without encountering a B, that means, and also because there's still a 2, there was no B's before the first A, and there was no B's after the first A. Therefore, we need to transform everything into a C, which is what we do here. Okay. From Professor. Just go ahead if you want to. I won't be objected to that. P.S. Do you think someone would think this story was real if you add a work of fiction note? Question mark. Who knows? But in any case, that's that. We did it. Very cool. Okay, and with that, forms the end of A to B. Thank you very much for joining me on this wonderful journey. It was a very long episode. I didn't expect the last 2 problems to be quite this difficult, but then again, It's quite a difficult language to master. So I hope you have a good time, and I'll see you another time. Bye bye.